Organic light-emitting diode, OLED. Think of the organic light-emitting diode, or OLED, as the absolute pinnacle of current display technology. While we spent a lot of time talking about the different flavors of LCD, like TN, IPS, and VA, those technologies are all essentially cousins. They all rely on that sandwich architecture where a backlight shines through a shutter. OLED changes the entire game by throwing the backlight in the trash. For your CompTIA A+ exam, and for your future work in cybersecurity, where you might be staring at high-resolution monitors for 12 hours a day, you must understand the physics of self-emissive pixels, the incredible performance benefits they offer, and the very real, organic expiration date that every technician needs to worry about. The physics, self-emissive pixels. To understand OLED, you have to look at the word organic. In this context, it means that the pixels are made of a carbon-based material that glows when you hit it with electricity. In a standard LCD, the backlight is always on. If the computer wants to show you a black screen, it has to tell the liquid crystals to twist shut to block that light. But as we discussed with IPS panels, those shutters aren't perfect. Some light always leaks through, which is why black often looks like dark gray. In an OLED display, every single pixel is its own independent light source. If the computer wants to show you the color black, it simply tells that specific pixel to turn off completely. There is zero light. This creates what we call infinite contrast, because the dark part of the mathematical contrast ratio is literally zero. The image pops with a depth and realism that no LCD can ever hope to match. The performance, beating the speed of TN. We previously called the TN panel the speed demon of the LCD world because of its fast response times. But OLED makes a TN panel look sluggish. Because there are no physical crystals that need to twist or tilt, the response time of an OLED is nearly instantaneous, often measured in 0.1 milliseconds, for a technician or a gamer. This means there is absolutely zero motion blur. Whether you are scrolling through thousands of lines of terminal code on your Ubuntu machine or watching a fast-paced video, the image remains perfectly sharp at all times. Furthermore, OLED inherited the best trait of IPS, the viewing angles, because the light is being generated right at the surface of the screen, rather than deep inside a sandwich. You can look at an OLED from almost any angle and see perfect, vibrant colors without any shifting or washing out. Physical versatility, thin and flexible. Because OLED removes the need for a bulky backlight and the thick layers of an LCD sandwich, the displays can be incredibly thin, sometimes as thin as a few sheets of paper. This is why you see OLED dominating the mobile market. It allows smartphones to be thinner and have larger batteries. More interestingly, the organic material can be printed onto flexible plastic instead of rigid glass. This is the technology behind foldable phones and curved wearable devices. As a technician, you'll see this most often in high-end laptops and mobile devices where weight and thickness are the primary concerns. The organic problem, burn-in and decay. Now, we have to talk about the dark side of OLED as a technician. This is what you will be troubleshooting. The word organic isn't just a marketing term, it means the materials have a limited lifespan. Every time an OLED pixel glows, it is slowly wearing itself out. Specifically, the blue organic compounds decay much faster than the red or green ones, over thousands of hours of use. The screen will slowly lose its maximum brightness and the color balance will start to shift. The most famous problem is permanent image retention, or burn-in. If you leave a static image on an OLED screen for too long, like the taskbar in Windows, or the heads-up display in a video game, those specific pixels are working harder than the ones around them. Eventually, they wear out more than their neighbors. Even if you change the image, you will see a faint, ghostly shadow of that taskbar permanently etched into the screen. For a cybersecurity professional who might leave a terminal window or a monitoring dashboard, open in the exact same spot for weeks at a time. This is a massive concern. Modern OLED displays use pixel shifting technology to move the image by a few millimeters every few minutes to try and prevent this. But the risk is always there. Power consumption and brightness. OLED is also unique in how it handles power. On an LCD, the power usage is mostly constant because the backlight is always on, regardless of what is on the screen. On an OLED, your battery life depends entirely on what you are looking at. If you use dark mode on your Ubuntu Lab machine, the screen uses very little power because most of the pixels are turned off. If you open a completely white spreadsheet, every single pixel has to glow at maximum strength, and your battery will drain significantly faster. Additionally, OLEDs struggle with overall brightness compared to the latest LED backlit LCDs. To prevent the organic material from overheating and burning out, OLEDs use an ABL, or auto brightness limiter. If a large portion of the screen becomes bright white, the monitor will automatically dim itself to protect the hardware. This can be frustrating for professionals who need consistent brightness for color grading or design work. Final comparison for the technician. When you are comparing OLED to the other three technologies, remember this hierarchy. OLED versus TN. OLED is significantly faster, has better colors, and better viewing angles. TN only wins on one thing: price. TN is the budget king. OLED is the premium king. OLED versus IPS. OLED has much better contrast and faster response times. IPS wins on longevity. An IPS monitor can stay on for 10 years without any fear of burn-in, making it a better choice for a static monitoring station. OLED versus VA. Both offer great contrast, but OLED's blacks are perfect, while VAs are just very good. OLED also completely solves the ghosting and motion blur issues that plague VA panels. By mastering the self-emissive nature of OLED, you'll know exactly when to recommend this beautiful, but fragile, technology to a client.